Over years, many researchers try to define digital twin. One of them mentions that digital twin represents a product, production process, or performance of a product or production system in operation. Another one is a representation of a physical asset that has a level of accuracy and includes information that allow the user to understand its behavior and performance. Also, digital twin concept combines the ideas of modeling and the IoT. So as you can see, there are lots of definitions of digital twin, but we can summarize it and say digital twin is a virtual representation of a physical object or a process. We can do simulation, we can do prediction, we can do analysis and optimization on virtual system without the need of actual device or a system. So now the question, what is the relation between IoT and digital twin? Digital twin is the creation of virtual replicas of physical IoT device, mirroring them in the cloud. This figure, for example, shows the concept of digital twin as a visual representation of IoT devices, enabling device as service. The main asset of digital twin is to implement an abstraction layer that allows IoT application to communicate with the devices. So from the very definition, it is clear that digital twins depend on IoT technologies driven by sensors, artificial intelligence, machine learning, and data analytics. IoT here acts as the foundation for digital twin, as it uses specific data about physical assets to help companies make better decisions. For that reason, digital twin is expected to increase IoT deployment, given the ability to add the value for end customers. Okay. When you talk about digital twin, you can't really miss Professor Michael Graves, who is a professor in Florida University, and he is the one who invented the word called information mirroring. So he was actually creating virtual model of a physical system, and he was actually done some research, but no one was noticing what he was doing until the NASA took the model and defined it as a digital twin. And they actually use it in their US Air Force, and then inwards all of these other companies like Siemens and different universities started researching in that. And right now it is really fast evolving field, as you know, as can you see now, right guys? So we have earlier looked at the definition of digital twin, and now we move into the next topic, which is the digital twin timeline. So let's see how digital twin have evolved and how actually modeling and simulation and all this process started. So we back in 1985 to 2002, there was a lot of focus on modeling and analytics, but it was basically bits of research and development and engineering focus. In 2003, the concept of digital twin was proposed, but not too much of work has happened by then. In 2010, NASA defined the concept of digital twin, and in 2012, digital twin was used by NASA and the United States Air Force. Between the period 2002 to 2014, there were some efforts made in manufacturing and the other sectors regarding product development, digital design, virtual assembly, and simulation. Looking forward from digital twin concept later in 2015-2017, some efforts have been made in the direction of IoT as an asset, remote monitoring, predictive maintenance, instant feedback across the entire manufacturing life cycle. A use case after that in 2017 to 2018, digital twin has been predicted as one of the top 10 trending technologies by Gartner. It will help in making devices or asset independent and self-healing. So what we do expect in future? 2019 onwards, the digital twin can be used for modeling using human and device collaboration. And there will be a lot of people awareness and intelligence. There will be a lot of mixed reality experience. So what will the digital twin bring in? It will give organization the visibility and the insight to operate the machine. So the data which is gathered from the sensor is going to make their business better, make them more powerful. We can also expect what could go wrong, and this can be avoided in the future. So this was a basic idea about digital twin and how they have evolved from the start to now, and how the future is going to be. So let's look at a very basic model of a digital twin. So let's say this is your physical process. It could be a plant or a manufacturing workshop. And what you are actually creating a digital model identical to your real model. But in order to operate your digital model, you need to give real-time data from physical model to your digital model. So now we have real-time data. What the digital model does, it does a lot of analytics, a lot of analysis, and then it feeds back to the physical model. So it optimizes certain parameters. The analytics would, result into saying that this pump must be for several pumps or must be operated at this temperature of that pressure to get the maximum efficiency and get the maximum production out of your process plant and so on. So it's like that. It's very basic in terms of this sketch which I am showing, but in reality it is a bit more.